So last but not least, we've got our intermittent activities, which I've done football here, for example. So with regards to analysing this activity, in the energy systems, you would use all of them depending on what you were doing at the time. So, for example, if you're sprinting to the ball, you're going to be using your ATP-PC system. If you're having to repeatedly sprint to the ball, you'd then use your lactic acid system. And if you're just the ball's gone out for a goal kick, and you're walking back to your position, then you'll be using the aerobic system. So with regards to fuels, you'll be using all of them, as in the marathon one, and waste products you'd have heat, lactic acid, carbon dioxide, and water. So with regards to heat, there's ways in which you can reduce it. So for example, pre-cooling, which involves having a slushy or wearing cooling vests prior to the event, which aid in the delayed temperature rise throughout the activity. This therefore leads to fatiguing at a later point in time, meaning you can last longer in the game. Also, wearing cooling hydration, is also a key factor in reducing body temperature by delaying fatigue. So, in football and in every activity, muscular contractions will take place, and responsible for this is our calcium ions, which is vital in the sliding filament theory. So in order to allow muscular contractions to take place, the sliding filament theory must also take place. The calcium ions are released into the cell, causing the filaments in the muscle fibers to contract. They're then pumped into storage to allow the filaments to relax. So this is how muscular contraction takes place. So in tired muscles, so once you've played, I don't know, however fit you are, played 70 minutes, you're getting tired, the channels will leak calcium ions, which weakens muscular contractions due to the release of a lowered amount of calcium from the sarcoplasmic reticulum, so therefore causing lower force generation. Now moving on to acetylcholine depletion. Acetylcholine is required to transfer nerve impulses across the synapse and to initiate muscular contractions. So in order to initiate a muscular contraction, enough of the acetylcholine has to reach across the synapse, otherwise no contraction will take place, and this is referred to as the all or none law. This therefore will lead to fatigue, as no muscular contraction can take place. So cholinesterase depletion, or excess amount of it, could also affect the uptake of acetylcholine back into the presynaptic membrane. So cholinesterase is an enzyme that breaks down acetylcholine so it can be reused again and transferred across the synapse, so that repetitive muscular contractions can take place. In order for another contraction to take place, this enzyme must remove the acetylcholine from the synapse. Therefore, if there's not enough of this enzyme or too much acetylcholine, then fatigue will occur, as another muscular contraction cannot take place. And lastly, talking about nerve impulses, if you've got an increased amount of hydrogen ions from the buildup of lactic acid, for example, it causes a lower frequency of nerve impulses, which therefore results in a lower force generation. So, sprinting to the ball, for example, or closing down an opponent, you'll be slower, so you might not get the ball. And with relation to recovery, you're going to be using all three systems throughout the activity, so recovery time will be fairly slow as you're having to resynthesize a lot of ATP. So ways to aid recovery: nutrition, so obtaining a high carb diet, which can speed up the glycogen recovery process. So muscle cells are most receptive to carbohydrates sort of in a 2-hour period after training has taken place. So after a game, taking a lot of carbs would be best then. So it's said to consume about 300 to 400 calories shortly after the training, and then a further 300 to 400 within 2 hours of that time. Another way is through cryotherapy, which is sort of like ice baths. So this helps reduce muscle soreness and prevents muscle strength loss. You can also take part in an active cool down, which aids in the removal of lactic acid, reduces the potential of DOMS, which is the delayed onset of muscle soreness, and it also reduces the chance of fainting, as it maintains venous return, therefore blood's constantly getting around to the muscles and back to the heart and to the brain stuff, so you're not likely to become dizzy. And it also reduces adrenaline level in the blood and allows the heart to return back to resting levels. And finally, not only are there physiological ways, but there's also mental ways. So, for example, controlled breathing and meditation can also help.